my name is Zura,
My name is Andre.
and this is the hardware team of OpenTags. Nice to meet you.
Hi, I'm Mohak, and I'm probably losing my sanity.
Hello, I'm Jason, and I have no clue what I'm doing.
Hey, I'm Jad, and we are the iOS and firmware team of OpenTags.
I'm Chris, and I'm part of the iOS team. No idea what I'm doing.
Ladies and gentlemen, welcome to the OpenTags Keynote 2024. Apple AirTags are a gold standard to track physical objects. However, their hardware and software cannot be utilized to their full potential due to their proprietary nature. OpenTags is our solution to that, using commercially available parts to replicate the functionality of Apple AirTags in an open source environment. To do so, we bought off-the-shelf components like a DWM 3000 chip from Corvo, a Xiao NRF52840, a lithium-ion battery, and a rechargeable battery component, all into a custom PCB. So our goal throughout this quarter was to create a tag that would allow the U1 chip on the iPhone to communicate with our tag through UWB signals. And this is how we did it.
Hello. Now we'll discuss all the hardware iterations that we've made during this class. So initially, we started off with just making a dev board. This dev board includes DWM and ESP32. We just created a dev board just to make sure all the components were selected properly and that it works. We also had a battery charging module that we tested to make sure that the battery is being charged properly. After this iteration, for our second iteration, we had an ESP32, DWM, and the battery charging module all included in the same board. We scraped some components for our future iterations since the components were expensive, but these boards also work. For our third iteration, we had an NRF, a DWM, and a battery charging module. We switched from ESP32 to NRF because of the middle compatibility issues that arise in the middle of the class. However, now this board is able to both communicate properly to the DWM, have a battery charging module, and it's extremely easy to add a wireless charging module, as can be seen here.
This is the current iteration of our PCB schematic, and every iteration of this schematic, including future iterations, will be publicly available on GitHub in case you would like to try to build it yourself.
As Hardware mentioned, we initially configured the firmware for the ESP32. However, midway through the quarter, we realized that we needed to use Apple's nearby interaction framework. In order to do so, we had to adapt the Apple and Corvo's proprietary middleware and protocol.
This middleware relies on the ARM Cortex-M4 CPU to configure the initial handshake using a communication link like BLE, which is why we switched on over to the NRF.
As soon as we build our app from Xcode, it's going to ask for permission for Bluetooth. We'll go ahead and allow. Once we hit allow, it's going to show the connection state to the OpenTag, which is connected. Once the OpenTag connects to the iPhone, then we can, it will show connected to unknown, which is our OpenTag. We can hit run session. It's going to ask for another permission for third-party accessories. We'll hit allow. And then it's going to show the accessory UWB state is on. It's going to start doing the handshake. But because we haven't integrated double-sided two-way ranging, it's going to do this loop of handshake. On the serial monitor, we can see the data from the OpenTag, and then on the logger from Xcode, we can see the data from the iPhone being sent and being received.
And thank you so much for those lovely demos. What you just saw were our MVPs for our hardware, iOS, and firmware teams. But due to mid-quarter changes and time constraints, we were unable to reach our stretch goals. Those being a better enclosure, a smaller board, improved and accurate, secure, double-sided two-way ranging, and an improved UI for our iOS app.
So that's it for today, folks. Thank you so much for coming to our keynote.
And don't forget,
Stay open!